So I hope the basic concept of stacks and queues everyone is kind of aware, right?
Yeah, sort of.
Yes. So we know, right? Stack is first in, last out, right?
Yeah.
So it's kind of putting a plate one over each other, where you put the first plate at the bottom, you stack it on top of each other, right? Each and every plate, and if you want to take the plate out, you have to take the last plate out, right? That's a typical stack implementation. So even in memory, it's not entirely stored like that in a memory. In memory, it is stored differently as a linear data structure. Maybe let me go to. Generally, how we can visualize is like we know, right? It's a kind of a stack, right? It's a bottom. So you fill the element here. First element will be here at the bottom, and remaining elements kind of arranged over the top of it, right? So if you wanted to remove something, it will be removed here, right, at the top. So, but in Java, the implementation is a little different. It's a kind of a linear data structure. Means you will have something like this. It will be stored in a linear memory location like this, where the last element added will be here, right? And the first element added will be here. So if you wanted to remove something, it will be removed from here only, right? If I wanted to, we call as push and pop, right? In stack, push is something which you are pushing into the stack. We can visualize something like this. You're pushing something into the stack. So popping is something you're taking out, right? If you're taking out, this particular thing will not be there, right? It's kind of removing the last element from the stack itself, right? So we call it as push and pop operation, not add and remove as we call it in ArrayList. And there is one more important method in stack called peek. Pop operation just to remove the particular element from the top of the stack, it just remove it. But whereas peek element just have a look at it and just goes back. It doesn't remove the element. Right? It's very useful in some scenarios. We'll see. It's kind of basic only, similar to what we saw in previous array list and linked list and hash maps. A similar implementation. You will not find much differences actually. So similar way to declare, let's say, integer. me just to try to run this. And see, right, it is just similar operation. Instead of add and delete, we have push and pop operation here. So if I wanted to pop out something here, I can. So the last element will be popped out. So if I have a, if you look at this, it has okay. One more important thing I have to. It implements something called vector. Actually, we'll see that, and we can add. We can clear and adding something which returns a boolean. You can see here, right? Boolean. So if it, we'll check if it contains or not, right? And we can check what's the first element. It will return that first element. We can get the index of each element. Similar operations, right? Index of, if you give pass the particular object, it will return the index of what element you are passing into the argument. You can check if the stack is empty or not. We can check the what's the last element, and we can iterate, right? And this is also this is something called peak, right? I'll just show this method. So after removing the last element, we're just peeking the second element. Peek means it will not remove, right? It will just access the second element and will just return that element. So in this case, the last element is 2 after removing 3, right? Just return. And after that, if we try to print remaining stack elements, it will print 1 and 2, right? Peek is also an important object. And
So
if you
seeking the last element is like a second element or the last element? Last element, right?
last element, which is number 2. You don't have to
Okay.
consider this as a first and second element. Index start from 0. You just
Okay.
consider this. We'll something like this, right? So it is just picking the last element and returning the results. Will not remove from the stack. It will
Okay.
just maybe, and it will just peek it, and if you try to print the remaining elements, it will print on, I mean, the first and second element, right?
Also, about the pop, since the stack follows first in last out, that is the only reason the pop is deleting the last element, right? Because last element is always deleted in stack.
Yes, yes, yes.
Okay.
Fine, right?
Yeah.
So you have this particular thing called remove also, but you don't have to necessarily use it in the stack because it's very costly operation again, right? And so can you explain like why it's a costly operation?
Mm, because might be we need to tell the index for remove and pop, since like pop deletes the last element, so it would directly delete the last element, and for the remove we have to tell the index. It will iterate through all the index and then it would remove that element.
Okay, removing that element and putting all the remaining elements together is a huge task, right? The elements present
Yeah.
before that and element present after that, we have to place it in a linear memory location. That is also a very huge task, right? So because of that, we prefer always linked list for these kind of operations. So if we go to the stack, it extends this class called vector, right? These vectors actually, okay, what we'll see, what's an vector actually. We just, vector is something, it's similar to a array, right? Array list, but with only one difference actually. uh, Vector is thread safe, whereas array list is not thread safe. That is the only difference. Right? So when I mean by thread safe, if 2, 3 threads are trying to access the same array list, then it might be a problem in an array list, right? There might be some situation called a deadlock, where you don't want the situation because the program execution will stop if two threads are trying to access the same array list over the memory. Whereas in vector, it's kind of array list only, but with thread safe implementation, where if even if 2, 3 threads are trying to access the same vector, then it will wait for another thread to stop and complete its things over the particular vector, and then it will give the access to the second thread. So that's the only difference. It implements this vector. So all of this particular index things, um, and many elements are coming, many things are coming from vector only. If you can see, stack has this push and pop operation, right? I mean, these are the methods which are explicit to stack, which doesn't have to necessarily be in the vector class. For example, if I search for push, it's not there, right? Push is not there. Pop is not there. So these are the things which are explicit to stack class only, right? Because stack only can provide the implementation of all these things. Vector cannot provide, right? So only if you want.
What is a vector class here? मतलब, what is implementing the vector class in stack? What is the role of vector in stack?
Stack is extending the vector.
Okay.
So if you see here, so if this push method is there, right, is of type stack, right? But if you see some other method, see this add method is of type of vector, right? Add all
Yeah.
is, I think it's again type of vector. Add element is vector, capacity is vector, clear is vector, clone is vector. So most of the things here are from vector class only, right? Only few things. If empty is from stack, again equals is from vector, first element is from vector, right? See, if you, most of the things are from vector only, last index, and only few things are from stack. If you can see the difference here, right? So what I mean to say is like, so only it's kind of almost similar to an array list, because vector is also an array list with only difference of thread being a thread safe, right? So only this finding the index and adding the element and removing the element method is also there, whereas stack has only push and pop element pop methods.
Okay.
So one of the famous problem in the stack space is like, okay, this is this is one of the famous yeah, very famous problem of using a stack, like balancing parentheses. It just the expression has only this kind of parentheses. This is assumption, only square brackets, rounded brackets, and braces. So if you find the opening braces, push into stack. Also, if you find the closing braces, then you have to have some logic here. If the stack is empty, then you should pick what is the particular character, and you should do necessary operations. You do check out this problem. It's kind of very frequently asked problem in questions if they wanted to ask in stack actually.
Karthik, can you explain this? I'm not getting this after push. Like what happens exactly? Like if the character is all these three brackets, we are putting it in a stack, and if these are closing bracket, then what we are exactly doing?
So we are checking if stack is not empty. If stack is empty, doesn't make sense, right? If the closing brackets are encountered.
Yeah.
So so if one of the closing brackets comes, then what we should check is like the previous opening bracket should be closed, right? Anyways, so we are picking the last character of the already available string, right? We're iterating the string here, right?
Yeah.
So we are picking the last character while iterating. If it is this particular opening braces rounded brackets, then the current available current thing should be the closed bracket only, right? Because that only makes sense.
Okay.
So again, if it is this curly braces, it should be the curly braces for the closing thing. If it's a square, it should be square of closing thing, right? If this condition is not matched, then obviously the thing is not balanced. Then it will return the empty. I mean, it will return not balanced, right? And if it is balanced, then it will pop. It will take the last element from the stack, right? Last element is what, either might be this or this or this, right? Because we are only pushing these elements in stack, opening braces in the stack, right? You're getting my point.
Yeah. I'll be needing थोड़ा अलग time. I'll try to read this and try to run this program.
See, we are pushing the opening brackets inside stack. So what we are doing, when any closing bracket comes, we are checking if the stack is not empty.
Yeah.
If the stack is empty, it doesn't make any sense. So we'll running not balanced. Again, this condition also should match, right? Um,
Hmm.
because if the opening, I mean, if the last element in the stack is the rounded brackets, then the current element should be this rounded bracket. Then only we can say the parenthesis balanced, right? For example, if you see here. Uh,
Yeah.
so these are opening braces, right? Round, square, and curly. These three will be pushed. Now all the three will be in the stack, right?
Yeah.
What is the top element in the stack? Now,
Uh, the third one, curly
yeah,
braces one.
opening curly braces, right?
Yeah.
Now the iteration will come to this closing curly braces.
Yeah.
Okay. Now we check out the condition. If this is opening curly braces, then immediate element should be closing curly braces only. Then
Right.
only we can say it is balanced. Right?
Yeah.
If the opening curly braces this one and closing is the round bracket, then it's not balanced. Right?
Balance. Yeah. Right.
So in this if condition, we are checking if this is a if the open this is we are peaking the character, and we are checking if the peaked character is this, then the closing character should be this one only. Right?
This one.
Yeah.
Got
Then the
it.
condition true. Then we are popping out from the stack, removing the particular element from the stack. Then the top of stack becomes the square bracket, and we are moving to the next thing, this particular square bracket. Again, the condition will match, and we are popping it out.
Karthik, in this case, like what
What? I didn't get your question.
yeah, yeah. So in this case, like after the this curly braces,
Hmm.
what will happen if the code stops after the curly braces? Like last two curly braces would not be inserted. Only the first three elements have been pushed, and then on comparison, we got the last picking element closing curly braces,
Hmm.
which got compared with the last third
Yes,
picking
yes, yeah,
element.
yeah. Mm-hmm.
And what if the last two elements have not been inserted, matlab have not been found? In that case, how will we'll get the not balanced thing?
So here we have one more else condition also, right?
Okay.
So we are checking what if the character is in the not in the proper order. This one, then again it says it's not balanced, and we are also checking if the stack is empty or not. For example, if we have only these first four elements and not the last two elements are not there, assume that, okay.
Yeah. Yeah.
Now we are popping out, we are pushing all the three elements in the stack, right? And if the
Yeah,
fourth
right.
element is closely braces, then one element will be popped out from the stack. Now,
Yeah.
if it comes to the end of the iteration, the stack will not be empty because the first two elements will be present in the stack.
Hmm.
So again, if the stack is not empty, then we are saying not balanced. If you come to the else condition directly.
Okay.
No, it will be confusing only. I ask you to please do this problem.
Yeah, yeah, yeah.
Uh,
I'll do by myself on. Like anyhow, we have to do this by our own. That is little confusing.
if you just go to the debug mode of Eclipse, then if you can go this step by step, then it will be kind of very useful.
Sure, 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 Karthik.
This condition matters, right? These two conditions are important: checking the stack emptiness and checking
If
the corresponding
condition
opening with closing braces.
basis. Hmm.
These are all about stacks. Again. And Q, we know, right? Just opposite to stack. FIFO, right? First in, first.
Karthik, other than balancing parenthesis program, can we know other important questions that might ask on a product-based companies?
Okay, even recently I solved one problem. It is also related to stacks only, but kind of related to parentheses only. I just show that
Okay.
problem actually. Yeah, aware of that lead code, right?
Yeah, you only told me.
Okay, just to show that problem actually. So there is one problem called balancing parenthesis. There's another problem called longest valid parenthesis, right? If the parenthesis, see, for example, the parenthesis might be balanced by not balanced. That's not the problem. But what is the longest valid parenthesis? In this particular example, the last two elements are valid, right?
Okay.
So now the
Yeah.
longest valid parenthesis is 2. Yeah, right?
Okay.
So in this particular string, how much is valid? 4 is valid because the middle 4 elements are valid, not the first and last elements, right?
Last element.
Now
Yeah,
the
right.
longest valid parenthesis is 4, right?
Okay.
So here 0, right? So if you go to the solution, then they might have solved in different techniques. One of the technique is using stack. Right?
Okay.
So just see this logic. This is also kind of an important question only. Most of the stacks problem is almost related to these kind of things only.
Okay.
Because we use stack to solve these kind of problems only, right? So first half will be kind
Yeah.
of similar to second half. For example, we can use stack to solve this problem. What to say?
Okay.
Reversing of string will be the same as original string, right? What's that? Anagram. What is that?
Anagram.
No, anagram. I think anagram. I think.
Yeah, actually, I recently gave an interview, so this has been asked to me.
Okay, you're getting it right. Where the stack is
Yeah.
used.
Yeah, right. But since I was not so aware about stack, so I tried to solve this problem without stack. Though anyhow, I got to solve this program,
Mhm.
but I solved without stack.
Okay. I mean, any problem can be solved using any of the data structure. That is there, but there is always a question why we use these kind of data structures actually.
Okay.
Right. So, for example, if any problem is asked in your interview, it can be
Mm-hmm.
used. I mean, for example, uh, finding some elements or anything for that matter can be used using a single data structure called array list. But why we have linked list, trees, maps, and those things?
Yeah.
Um, can you just say like Can you just try to explain like why we have all those data structures actually?
Just to refactor our code and to maintain our code more effective way. Like if we use data structure, our code can be reduced to a short lines, and our memory can be like more effective in that way. But other than that, if we try to solve that problem with any other way other than these data structures, more memory can be consumed and more lines of code is used, which is not readable and might be complex.
Okay, whatever you're saying is partially correct. That is
Okay.
called space complexity, right? So space complexity
Okay.
of a problem is something which when we try to solve the problem, and we should not access the so many space in our RAM, right? It's a very very important criteria.
Okay.
There are two concepts actually. You said this correct only. It's one of the answer. Right? There are two important things when we have to consider. One is time complexity, other one is space complexity. So whatever you said is space complexity. That's also very very important. Uh,
Okay.
so when we are trying to do some data operations over a very large data set, you declare some temporary variables temporary to store and process this data, right? To just do some operations over the particular input data set. But creating these temporary variables also increases the memory. You're getting it right. You're creating temporary variable, pushing some data into that, and taking the data after something. So it will also increase the our memory. Space in the memory RAM. So it is not a good solution to always kind of not considering the space complexity thing. Whenever you
Okay.
do a program, space complexity is also very very important. If you run out of memory, then program cannot be executed. Right? Memory is a finite resource. 4 GB, 8 GB, 16 GB. Those things
Yeah.
only will be there. So one aspect is space complexity. Another important aspect is time complexity, right? For example, in a particular sequence, your particular thing will execute in 1 millisecond or 5 milliseconds. If you don't use a right data structure, probably that program will be executed for 500 milliseconds, even 5 seconds.
Okay.
Sometimes, if you don't optimize the code, few codes, many times, many programs are into problem like sometimes if you don't use a particular data structure, a program which supposed to be executed for 20-30 minutes will execute for hundreds of years, actually years. It's not days or months, it's years.
Okay.
So,
So, you mean to say the data structure reduces time and space
yes,
complexity?
yes.
Okay.
Using right data structure will improve time and space complexity.
Okay. So, like if in an interview anyone asks a question, they don't ask like implement with stack or queues. They just give the program and we try to solve it. So, like we should know the better approach for time and space complexity.
Always,
Otherwise, like
always.
if we are solving any program and if we are getting the right output, irrespective we have used the correct data structure, is that the correct approach? Like no one would suggest that do with another approach.
No,
Are
no,
they
no.
looking
They
for
will
the
ask like what is a better approach to
mm,
do that.
okay,
So you should understand either you can use a better data structure or you
okay,
can use algorithms to better solve the problems, right? That's called data
okay,
structures and algorithms, right?
okay, okay,
So both the things will try to optimize your code by reducing time and space complexity.
okay.
Either you can use proper data structure or proper
Hmm.
algorithm or combination of both.
Okay.
So one typical example where this applies is like where both the things combines is like, for example, I think this is the first problem in series. I think. Just try this to some problem actually. So they will give some input data set, right? And they'll give the target number. You have to find what are the pair of elements which will lead to the input. Target here in the particular data set.
Yeah, I tried to solve this with the help of lead code only once.
So what's a normal? thing to do actually, right? So normal thing to do is like kind of iterating each and every find and every combination by having two for loops, right?
Yeah, right.
So instead of that, why can't we have something like hash set to do that? Maybe I'll try to show if the problem is available or not. See, yeah, it's available. Okay. So we have two for loops, one for iterating, comparing first element, and second for loop is for comparing remaining elements with the first element, right? This
Yeah.
is, see the time complexity. Time complexity is n square. N square because we have two for loops, right?
Yeah.
But this is the worst case of solving any problem. But with the use of right data structure and right algorithm like hash table, what we can do, you can declare a hash map like this, and we can put the sum here, right?
Okay.
And for using one for loop only, and we can get the sum from the hash map and compare with the element which we are currently iterating. So if it matches, then I mean you have to subtract both the things. See, you're separating here, right? Target minus. So if the result is 0, then obviously the both will add to a particular number. Okay? So we just, if the result is 0, then we print both the indexes of the number. Now the time complexity is drastically reduced, right? Just to see this problem, it's kind of very interesting problem to solve. Now instead of n square, we have only order of n as a time complexity.
Sure, Karthik.
So this is one typical example, and it's also frequently asked problem in coding interviews. This problem, and there's one more problem called okay. This is also important, very very important for longest palindromic substring. Okay, the thing I was mentioning was palindrome actually. Anagram is something which is jumbled words, right? If words are also jumbled, if the original input string has all the words, then we call that as anagram. Palindrome is something which we reverse the entire string directly, right?
Yeah.
So in this case also, it can be solved using stacks. And okay, this threesome is also very very important. Threesome is like any three elements which sums to 0 or any given number, right? What are those three elements in the given set we have to find? So in this particular input array, there are two sub arrays which will lead to the total sum of 0, right? So this is also
Okay.
very very important, little complex problem, but important problem to solve. It uses different actually kind of not data structure, kind of an algorithm to solve a particular problem. You just read this kind of very very interesting algorithm to solve actually.
Okay.
Just try to solve this problem. Fine. I mean, can we move to queues or any other things to discuss?
Yeah, we can move to queues.
Mithun, is that okay?
Yes, Karthik. Okay.
Okay. Again, queue we know, right? First in, first out. It's kind of this particular guy is coming to the queue, and second guy will be added here. Third guy will be added here. Fourth here. And if someone wants to get out, he'll be the first one to get out because it follows a queue order, right? He'll be first one to get out, then we'll have remaining 3 persons. If next person, if something wants to get out again, this will be getting out, right? Other 2 persons will be there. Again, it's kind of very very similar, but only few small differences are there with respect to queue. Queue is actually very interesting data structure to kind of explore. But queue problems are actually very very rare with respect to testing actually. But if you are trying for development profile and all, there is queues are kind of very important actually. Queues are used extensively in development. We'll try to. We'll just say queue of an integer. Okay. So in stack, what we saw is like we used the stack is equal to new stack, but in queue that is not the case because queue is an interface. It's not a class, right? If you go to this queue, it's an interface which extends the collection, right? So we have to implement the queue using something called array DQ, right? This array DQ, this implements DQ, and this DQ extends queue, right? Through this way only we can, I mean, kind of implement a queue. For example, if I go to
Queue itself implements what? Sorry, Karthik.
queue itself implements this DQ class.
Okay.
Okay. First, queue is a interface which extends this collection interface. Right? Collection is also an interface only, right?
Okay.
So we cannot do something like this. In the what I meant is like we cannot do something like queue. Let's say q1 is equal to new. We cannot do something, I mean, we saw these examples previously. Why we cannot do something like this while we learned interface? Why we can't do something like this? Anchal, can you?
Interface does not have any own method, so we cannot.
It has only method declaration, right? It does not have any
Method
implementation.
implementation. Yeah, right. So
So
we need
implementation,
any.
yes, implementation should be given by the classes which is implementing it, right?
Yeah.
So in the queue, what happens? There are three classes which are implementing this queue. One is array DQ, right? Now this array DQ class, which is implementing the DQ, again this DQ is extending this queue. So through this way, we are implementing this queue in our array DQ class, right? And we have also linked list class which implements this DQ, if you can see here, right? So I can have this queue something like this also. Something similar to this also. Instead of queue, I can put a linked list also. So that is also one thing, right? We'll just mark it as array queue. We'll link queue. And there is one more queue implementation called priority queue. This priority queue is kind of very extensively used in development.
So these array queue, linked list, and priority queue, these are all classes, right?
Yes. If you go to this priority queue, again, this class extends this abstract queue. This abstract queue again implements this queue, right? So these are the things which can be used to implement the queue in our program, right? So I mean, the things will be similar, almost similar for. If you go to this array queue, we have again add, clear. Those things are common only, right? So it will have this particular. See, all these are coming from queue interface only, right? This implementation, this peak, pole. This our peak is something which we peak at the top of the queue, right? And we don't remove it. And pole is we remove from the top of the queue, mean the first element from the queue, and we can get the size and those things. Similarly, if you go for link queue, also same thing is going to happen. Again, we have add, clear, and everything is same because these things are defined from the queue itself, right? Queue interface itself. Just these classes are providing the implementation. Okay. Same goes for priority queue. Adding, clearing, picking, pooling, everything same. Okay, Mithun, Anchal said she'll be coming back in 2 minutes, so I think we can wait.
Okay. Karthik, is there any difference between these three queues?
Yes, there is a difference. Array DQ is kind of an array implementation of a queue, right? It's kind of stored in a linear data structure, right? Queue elements are stored linearly in a memory, right? Again, it is used for inserting and deleting. This queue can be used extensively for inserting, deleting only. You can do the removing thing also, but it's going to be a very, very costly operation. Right? For example, so I have this remove method also, right? You can do that, but it's going to be a very, very costly operation. You have to be careful. So only we have three kind of array implementation. Linked is kind of a linked list implementation of a queue, right? You have a queue, but the elements are not stored in linear memory locations in our RAM. It's stored in the random memory location, only to be connected with help of the address information which is present inside the queue. I mean, the linked list, right? If I am in one particular element, I know the previous element address and next element address. So this is a linked list implementation of queue, and this is third one is a special queue because the data is not stored in the first in first out order. It stores it based on priority.
Okay.
So this is a special implementation actually. If I implement 1 2 3 here, if I implement 1 2 3 4 here, it not necessarily stored in that order, right? It will store in some order depend upon priority.
Priorities. Okay. Okay, Karthik.
So these are the two. I mean, these are the important difference between the queues. Other things are similar only. Welcome, Sagar.
Hi, Karthik. Sorry for joining late, basically.
No problem.
So it seems today's session is regarding array list.
No, it's regarding stacks and queues.
Okay, stacks and queues. Okay.
So it's similar only. So we can add an element to a queue and we can just print and we can probably pull the element from the queue. So if we pull the element, the first element is removed, right? In the stack, we saw the last element is removed, which if we pop, but in the queue, the first element is removed, right? So that is the major difference between a stack and a queue.
Adding an element in a queue is an ordered or an unordered, might be ordered only, right?
Okay, in array DQ and linked list, it's ordered, but in priority key, it's unordered actually.
Okay.
Maybe It depends. It depends upon many things. Maybe we'll try to. So we added in some order, but it is showed in some order, right? So it has some priority set for each and every element inside. You're getting it right?
Yeah.
Maybe we'll try to do this with.
And Q, we can say first in, first out.
Mhm.
Can we say Q as a first
Yeah,
in,
Q is first
out?
in, first out. But only difference, see, if it's a linked queue or array queue, it will store in the same order which we intended it to be there, right?
Yeah,
But
yeah.
what happens in case of priority queue is like priority queue is kind of special implementation of queue, where the elements is kind of stored in an order, not necessarily in first in, first out manner, but it depends upon the priority of element. Which there are many ways to do that, but we'll not see that detail with respect to priority queue. But understand that because priority queue is nowhere relevant to testing, it's used extensively in development. But understand that priority queue is special implementation of queue, where you can set the priority of each and every element. Depends upon that, its position will be changed in the stored element, right? Otherwise,
Okay.
array queue and link queue stored elements in a sequential manner in how we put the element in a first in, first out manner. That's not going to be a problem. So only difference is like array queue should be used wherever we need some linear storage of data structure, and only insertion deletions are there. I mean, only kind of insertion deletion at the end, right? I mean, the starting and then those things are there. If you want to do something in the middle, array queue is kind of very costly operation. Linked list implementation of queue is feasible. We saw linked list, right? Why linked list is used and those things, right? Linked list is connected by the address locations, right? My current element, I have address locations of previous and next pointers. So it's kind of very easy to insert an element inside the middle of linked list, whereas inserting an element in middle of array list is very costly operation. So we have to have those things in mind and design queues.
Okay.
So Karthik, this prior queue, based on what the priority is set?
It is set default by like what, for example, we just there is something called comparison and compare. Maybe I didn't talk about that. See, it has some internal logics, okay, right? See, this comparator things is there, right? You just to see what is this comparator. It sets the priority based upon this, right? We can also override this comparator and set our own priority, right? Comparison and comparable operators are there actually. Maybe we'll cover this in another session, right? Mainly from this comparator, right?
Okay.
So use this comparator to set the priority of priority queue. So we can override this comparator and we can give our own priority also. But understand that it's doing using those things only, comparator and comparable operators. Right? Just to see, Google it. Maybe we'll try to cover it in the later sessions.
Okay.
Right.
Okay, sure.
But the particular important thing is like queues are not kind of that much, or not even 99%. I won't say it is used in testing or
Yeah.
any testing frameworks. Maybe it's rare.
Yeah.
Any other?
Well, in that case,
Mhm.
suppose comparator, if we don't use in testing, I am thinking like, suppose there is one node, and the child nodes, I mean parent node is different, and under which child nodes are same.
How can that be
There are
possible?
two type of environment. Suppose if you say that uh, for laptop and sorry, the large screens, if
Okay.
I want to work on the browser which is in the large screen, and suppose I have done a different implementation for the small screens, means mobile screens.
Okay.
Okay, now what happened, that the parent node is different but the child nodes are same. I mean, the web application has been developed such a way that the parent application, parent node is same, but
No,
the child
what
node,
do you mean by parent node actually?
parent node means, suppose for the large device there is a ID which is called large device,
Okay.
okay,
Okay. Okay.
or the PC laptop. And the, for when the our web application will run in mobile browsers,
Mm-hmm.
the that node the another node will execute which has ID of small device.
Okay.
But the child node, suppose in the child node has logout button.
Okay.
Okay, and the parent node also has the same logout button with the same structure.
Mm-hmm.
So when a web application understand that it will run in a small device comparatively,
Mm-hmm.
then the block of code which has ID of small device, that will execute. But and when web
Okay, you
application,
want different implementation of the same device in
yes,
different screen layout.
yes, yes, same button with
So,
different implementation in
yeah, yeah.
different screens.
But where does comparator and comparable come into picture in this scenario? Where do you
Yeah.
think it will come into picture?
So suppose if we store the element, this the same element, logout element,
Mm-hmm.
that's that is situated in this both of the node.
Mm-hmm.
Okay. So if we use this prior queue,
Okay.
which use the comparator,
Mm-hmm.
so will that be applicable? I don't know.
No, it is totally different concept. Right? Comparator is something. For example, um, I'll just give you a rough example. If you want to compare numbers, what you will do? If your number is smaller or greater, what you will do? Just use the comparison operator, lesser than operator, right? That angle bracket, angle symbol.
Right.
So what if you want to compare two objects and
Yes.
sort the things based on object?
Okay.
So how will you do in that case? So in those cases only this comparator and comparable comes into picture.
Okay.
It is kind of not relevant to the example which you quoted. For example which you quoted, you can use the concept of inheritance, right? You have a base class which have that element, and there are two classes implementing it, but with a different implementation, right? So you can override the implementation in the base class and override it in the derived class. Right? That is a very good solution for this kind of problems. So your
Okay.
mobile overrided will have different implementation, different idea, something. Maybe some other device will have different idea, different implementation of the same thing.
Yeah.
So
Okay.
that is more relevant in this kind of example.
Okay. Okay. Okay.
Okay. I think we can wrap up the session. If anyone has any other question?
I need to study because I joined at the last 5 minutes of the session.
Okay.
I have to study.
I'll share the recording. Maybe we'll see
Yeah.
and we'll get back.
Sure.
Tomorrow is most probably the last class with respect to Java, I think. So from day after tomorrow, we'll start Selenium.
Okay.
Tomorrow we'll see something called generics. Right.
Karthik, if you have 2 or 5 minutes, I would want to share my
Yes,
screen
sure,
and
sure,
want
sure.
to discuss one anagram program.
Sure.